Okay, so today we're going to talk about monomial factors of polynomials. Just looking at the topic, anybody have any guess as to what we're saying? What we're going to do? Any ideas? Yeah? No? Okay. Yeah. We're going to factor something. You're right. You're right. Very good. Now, what does it mean to factor something? Yes?
So like see what numbers were multiplied.
So, say it again. You almost got it.
See what numbers were multiplied to get that.
Exactly. To see what numbers you need to multiply to get the original expression. For example, here's our first one. Look at the instruction. It says to factor. It doesn't say simplify, because if it did, then you're done. There's nothing to simplify. But they ask you to factor this, okay? And we're going to get a monomial fact out of this. So when I say factor 15x squared minus 9, in order to factor, yeah, do you have an idea?
Well, is it like if they both go into a number, then we can do that?
Yes, we're looking for a factor that goes into both of these terms. By the way, isn't this already factored? Somebody says this. Oh, wait, isn't this 15x squared? Isn't this already factored? 15 times x squared, that's multiplication, right? Because what does factor mean? You write it as a product, right? Isn't this a product? It's not? Yeah, Kaylee?
Well, it's not really because 15 divided by 3.
Yeah, you're right.
X.
Uh-huh. No. Yeah, so you're exactly right. Victor? Do you want to say something? Oh, no. Okay. You were saying, okay, so what do you think I should write this as?
One way to write it is 3x minus 9, 3. I don't know.
Yeah, not quite. So when we say factor, let's kind of step back a little bit. What do you think I mean by factor? Yes?
You have to factor each one and like separately, like the 9 and 15 separately.
You could do that, you sure? Victor? You use greatest common factor. Why is that necessary? Because that's your step one. Every time you factor something like this, you use GCF. That's your step one. Does anybody know what the GCF of 15x squared and negative 9 is? Yes. 3 is a GCF. Would you not agree? Why? Because remember, what does GCF do? It goes into both of the terms, right? 3 goes into 15x squared. 3 goes into negative 9, doesn't it? So if I knew that, then it helps me to factor. Does anybody know, knowing that 3 is a GCF, how does it help? Yeah, Victor?
You divide everything by 3.
In your head, that's what you're doing. So it's going to be 3 times what? 3 times what gives you 15x squared minus 9? You know what I'm trying to say? William?
3 times 5x squared minus 3.
Yeah. Exactly right. So step 1 is to look for your GCF. And as you can see, this is what factoring means. Notice the whole thing is written as a. What does factor mean? You want to write something as a? As a, anybody? When you're trying to factor something, you want to write something as a? What did we do? Look at the whole expression. This expression was subtraction, right? It was subtracting this thing. Now it's written as a? What? Yes, sir. Yeah, well, only one part of it is. So in other words, what does factor mean? We've learned this before. When you factor something, you're trying to write something as a. Start with P. Yes? No. This is a polynomial, man. This is binomial stuff. Yeah. Product. Huh? Prime? No. I don't. Yes. Product is correct. When we factor, we want you to write something as a multiplication, right? Something times something else. Does that make sense? That's important to understand. So when we say factor, we want to write something as a product. And have we written something as a product? Yeah? Yeah, it's 3 times that binomial, 5x squared minus 3. Isn't that right? Do you see what I mean by factor? When I say factor, you want to write, keep this in mind, guys, because this whole chapter 5 is about factoring, okay? Whole chapter. It means to write something as a product. For most of the times, it's going to be write a polynomial as a product. Does that make sense? Well, what about my original polynomial? Isn't this binomial product? Because it's 15 times x squared. That's a multiplication. Isn't that a product? 15x squared. Isn't that 15 times x squared? So isn't that factor? I wrote that as a product. But that's not really factored. Why not? Anybody? Yes, sir.
You can't factor anything out like 15
No. Now, when I say write something as a product, the whole thing. Do you see how the whole thing is a product? Not just one term of it as a product. I want the whole polynomial written as a product. This is 3 times this whole thing gives you 15x squared minus 9. Does that make sense? So when I say write something as a product, I mean write the whole polynomial as a product, not just part of it. Does that make sense? That's what we mean by factoring. Okay. And again, if you remember, look, have we seen this before? 3 times 5x squared minus 9, 3. We've seen this before. What do we do with these sort of thing? We multiply it out using what property? Yeah, distributive property, right? So you see how we're now going backwards? We're used to going from 3 times negative 5x squared minus 3 to 15x squared minus 9, right? We distribute that. But now we're going backwards. Does that make sense? So when you factor, it's kind of like doing backwards of the distributive property, if you want to think of it that way. Does that make sense? Because after all, when you had something to distribute, you had something as something factored, right? It's something times the whole thing is a product, right? Does that make sense? Okay, as we do more, it will make more sense. Let's look at example 2. So I'm going to ask you to factor again. So is this factor right now 28x fifth minus 12x cubed plus 20x squared? Is that factor? Is that polynomial factor? No, it's not written as a product, is it? It's written as a sum, isn't it? But not as a product. Does that make sense? Well, some may say, well, isn't that subtraction? Yeah, but that's plus negative 12x cubed, isn't that right? So it's really written as a sum, not as a product. It's not written as a multiplicating some things together, right? So go ahead and write this down. Guess what my first step is? Yeah.
Simplify.
It's already simplified though, you're right. So we can't really so then if I want to factor, my first step is find the greatest common factor of each of the terms, right? Does that make sense? Everybody go ahead and try. Go ahead and find the greatest common factor of each of the terms. GCF. Find the GCF. Okay, a lot of you guys are fast. So who's got this? Ethan? 4x squared. How many people agree? 4x squared is okay, a lot of you. I think you are. Step 1. You are correct. You see how I'm doing this work kind of off the side, right? Because, by the way, then what? So I found that the GCF of each of these terms, 28x fifth minus 12x cubed plus 20x squared, each of these terms, the GCF is 4x squared. Oh, 4x squared. So in your head, you're thinking, okay, 4x squared times what gives you 28x fifth? Anybody? So I'm going to put in parentheses. Isn't that what you're thinking in your head, right? So since I know that 4x squared is my GCF, right, that is a greatest common factor. We could factor that out. So it's going to be 4x squared times something gives you 28 to the fifth. Who can tell me? Ben? 7x cubed minus, right? It's minus. There's minus there. Minus who? Sarah? 3x plus what comes next? How about Austin?
That's 5x.
5x? You sure? Because what's 5x squared times 4x squared? Does that give you 20x squared?
Oh, yeah.
So you should write this as, that's not correct, so you should write that as 4x squared times what gives you 20x squared? Because that's what you're thinking in your head, right?
5x.
Times what? 5. That's all you need, right? Does that make sense? Do you think it's a good idea to check and see if you got the right answer? How do we check this, by the way? You? Yeah. Distribute. See if you got it right. Do you think that's a good idea? Does that make sense, guys? So as you can see, we have now factored that trinomial as 4x squared times this whole trinomial, 7x cubed minus 3x minus 5. Okay. Any question? Are we good with that? Okay. By the way, why is GCF nice to factor out? What is GCF, by the way? It's called greatest common factor, which means you think that 4x squared is a common factor for each of these terms? Yeah, that's why we chose greatest common factor, you see? So you know, it has to always factor out. You see what I'm talking about? Do you guys get the idea? Okay. Okay, if you really understood the idea of factoring GCF, go ahead and do this one now on your own. I'll give you time and see how many people got this right. Everybody try. Okay, Olivia, can you tell me what my GCF is? I mean, Viviana? Olivia, where did I get Olivia from? Huh? 5xyz. How many people think that that's your GCF? Do you agree with Viviana? 5xyz. Is it 5x squared? Oh. How many people agree with 5x squared yz? I think that's correct. Good. Because remember, we choose the smallest exponent of the, right? The common factor. For x, you know, this is x to the third, x squared, so you choose x squared. Now, knowing that that's my GCF, who can then tell me how to factor this? One person? 2, 3, 4? Claire, can you help me out? I'm going to have, first of all, yeah, 5x, so I have this, and then? There you go. How many got this? Raise your hand. That's your answer. Okay. Inside the parentheses, you get 3xy minus 4z, right? And do you think it's always a good idea to check and see if you have the right answer? Yes? Yeah, always check, right? Yes. Are we good with these? So always check and see if you have the right. So distribute that GCF and see if you get the original expression, right? That would help you. Any question? No? Okay, now before I get going, how many people remember this fact? If I have a plus b over c, what was this fraction before it became a plus b over c? Because we need to kind of remind ourselves. 2 people know? That's it? What was a plus b over c? Yeah, Alvin?
A over c.
Yeah, a over c plus b over c. Isn't that how it became a plus b over c? Would you not agree? Okay, what about the other one? What about this? ab over c. What was that before? It became ab over c. 2 people? That's it? 3? 4. What was a times b over c before it became a b over c? Okay, how about Audrey? Is it a over c times b over c? Not quite, because if that was true, your denominator will be c squared. You want to change your answer?
Is it
A over c is correct. A over c times?
times b?
That's exactly right. A over c times b, which is a over c times b over 1. Okay? Please keep that in mind. It's over 1, isn't it? Because if that denominator was c, you would get c squared on the denominator. Does that make sense? Yeah.
Could it be flipped so that it would be a half?
Oh yes, sure. So sorry. So it could be, if you wanted to, rewrite this as Sarah. What would you write? It could be what? A over. Sure. B over c. Same thing. But it's one of them has to have 1 as its denominator, right? Because when people see this, the reason why I'm writing this is because when people see this on the left, they automatically think, oh, do not have the same denominator? No. This is addition. This is. The other one is multiplication. You understand the difference? Right, guys? It makes a huge difference, doesn't it? Okay, so knowing this, let's go to example 4. Are we okay with that? So example 4 says, now it's a little bit different. We're switching a gear a little bit. But you'll see why we did all that work in 1 through example 1 through 3 in a minute.